This video is brought to you by Iona, North America's premier charging network. With unmatched commitment to elevating the customer experience, Iona is opening America's roads to all EVs, giving drivers the coverage they need, the reliability they deserve, and the amenities they crave. This video is also brought to you by Eaton. Eaton is a one-stop shop for implementing reliable and innovative EV charging infrastructure at your site. Across all applications, Eaton's EV charging infrastructure, hardware and software gives you the scalability, flexibility, and intelligence you need to charge today and scale up tomorrow. Learn more at eaton.com/EVCI.
Welcome to another Auto Spec review video. Today we are in the UK, in Bristol, meeting the guys at Fellten. So you may know Fellten for their classic cars conversion systems, but they also do many other things that we had no clue before, from marine application packs to mega packs. So for a container filled with repurposed second life battery packs from EVs, from Tesla Model 3s and many others. And we're going to see with Chris Hazel how they managed to offer something no one else has ever offered: second life battery packs to recharge cars anywhere. And then you can plug it in with a Type 2 or a CCS, or even just use it as a big battery pack. So let's check them out. All right, Chris, thank you very much for having us and showing you your latest project. So we know you from Auto Spec. Yes. Renew, modifying classic cars, converting them to electric and shipping your system all around the globe. And then you did totally the opposite. Instead of building brand new battery packs, you're repurposing OEM packs into something new.
Big metal boxes.
Well, that's the best metal box that you could ever want to, isn't it?
Yeah, it is, because I mean it's a sea container. So this is a 20-foot sea container that's been cut down into 10-foot. And obviously in the UK, everywhere over the world, everyone ships loads of stuff into the countries, but doesn't ship much back out these days. So there ends up in stacks and stacks and stacks of these, just sat rotting away. So this is a single-use container that's been cut down and modified, and then we've basically taken battery packs from Teslas or other vehicles and allowed them to retire in a nice simple life inside of a nice warm container. So in here at the moment there is 2 Tesla Model 3 packs, but we can go up to 6 high, and if we go up to 6 we're at 450 kilowatt hours.
Wow, okay.
Yeah, a lot. And then we've got 50 kilowatt inverters in which we run multiples of these. The newer version does have the rack mount ones that you see in like charging stations and stuff, because it allows us to make it very modular, so we can chop and change it. We can do, say, AC charging, or we can do up to 240 kilowatt DC rapid charging.
Okay.
So, awful lot of charging speed. The batteries allow us to do that because they can buffer it massively. So the joy with Qube is that we can basically have a really small grid supply, so something like a 32 amp 3-phase grid supply that's just continually topping this up all the time, but then someone can come along, plug their car in and pull 240 kilowatts at a point in time, because the batteries have allowed us to buffer it. The key thing here is you don't have to upgrade the grid. So if you've got a small grid connection, you don't want to go and pay hundreds of thousands of dollars to have the grid upgraded. You can put a couple of these in and just slowly charge up from the grid you have available, which saves a huge amount of money. And the best thing is, it's classed as temporary. So you can drop it, no planning permission, none of that extra stuff, which is absolutely great.
So that can be delivered anywhere, used for a day or a decade pretty much. Yeah,
yeah, exactly.
Yeah.
I mean, the containers themselves will probably last, say, 25 years. As most of us are finding out with EV batteries, the life expectancy on them is far longer than anyone ever anticipated. I mean, you're thinking most of these batteries will probably do 20 to 25 years of life expectancy with the components that are within them. And you think most EVs, once they get to 150, 200,000 miles, the battery's still good. Maybe 85%, maybe not even that now, looking at some of the capacity logs we've seen. And then once they go into one of these, the capacity and degradation is minimal, because they have such an easy life. You think this Tesla pack in a Tesla would do 300 kilowatt charging speed. In here it's doing, I think, something like 20 kilowatt charging speed. Admittedly, it does quite a high discharge when it's rapid charging, but you've got 450 kilowatt hours at that point and doing 240 kilowatt rapid charge. So actually, you're doing like over half of the loading it would have seen in the Tesla.
Yeah. So what are the use cases?
So the big use case for Qube, I mean, it can do so many things, which is what makes it such a great product. But right now, we are really focusing on fleets. Because if you think about it, most vehicles out there, which is saying like the Tesla, People have these day-to-day, daily use cars, but they'll sit in a car park for over 90% of their life, not used. Fleets are the ones that are using them every single day in, day out. But they're the ones that are struggling to transition, not just because they've got to go and buy an electric van fleet, but they've also then got to pay for a massive amount of charge infrastructure. So the benefit with Qube is they can rent, buy, lease a Qube, drop it on their site, which they do not own in most situations. I think that's the key thing here, is that most premises globally are not owned. They're rented or leased for, say, 5, 10 years at a time. You don't want to go and spend hundreds of thousands of dollars upgrading that premises to then give it to the landlord when you leave. So you use a Qube because it means you're not paying a massive amount of infrastructure costs. And it means it goes in quick, as in it's in a day or 2 days, and then suddenly you can start charging your fleet. And if we can get fleet to transition fast, that's going to be the key thing, because if you think they're on the road 24/7, at least all day long, and then they charge at night, they actually probably push most of the pollutants into the atmosphere. They're normally vans, trucks, they're normally running on diesel, so they're not great for the environment anyway from a particulate point of view. So Qube is mainly focused on how can we get fleets and bigger companies to transition to electric as fast as possible and just remove the barriers. There's always an excuse why they can't do it. Once you've got Qube in there and you've got that in place, it should stop them having those excuses. It should really help companies transition to electric.
And not only that, but also it has a very small footprint, about 9 square meters. Again, it's a 10-foot container. It means you could almost have this on a car park or parking lot and charge a dozen cars pretty much.
Yeah. So I mean, the smaller one like this, we're building these to have up to 12 Type 2/Type 1 chargers on them. And then we're doing the bigger ones at like 20-foot sea containers that can have up to 36 AC chargers on them. So you get really big. But I mean, the key thing here is you have the Qube itself, which has a charger embedded in either side of it. So you have one either side. This will sit in one car parking space and you can charge a car here, but then you move across and you have a pavilion. So these pavilions here plug in just here. So I'm going to make you move back. They basically plug into the side of the Qube just here, where you have your AC in from your grid supply or whatever, and then you have these outputs. So you can have multiples of these depending on how many chargers. And these then basically go along what you class a temporary cable tray, I suppose, and plug into the back of these pavilions. Now each one of these little pavilions is really cool because it looks like a miniature container. So it's basically rippled to look like a mini container on end, just because I thought it was pretty cool. And they're really sturdy. So these are solid steel, they're heavy, so people can reverse into them, because admittedly, if you're a van driver, you don't care about the chargers. You already don't want to be driving an EV in most of these situations anyway, and your company's making you do it. Once they start driving them, they love them, but you've got to get them into driving them, so they'll try and find any excuse. So this, sturdy, they can reverse into it and it still works. And then either side of this, you have a AC charger, which means you can put a vehicle either side. Then you have multiples of these all the way along the yard of the car park, which makes them absolutely great. So these are 7 kilowatts at the moment, but they can go up to 22 kilowatt as well, for if you need that faster charging speed if you have a larger battery. Now, one of the big things I keep getting asked all the time is there enough second life EV batteries? That was the reason we didn't do this years ago, is because there wasn't enough of them around. But what we found, which is quite amazing, is all these big fleet operators have thousands of Teslas or thousands of BYDs or thousands of ID3s, and they're looking at second life now, and what do they do with them afterwards? So say they've gone out on 2 leases and they're 6, 7 years old and they're on over 200,000 miles. What then happens to that car? The resale value is not crazy high. They don't want to go and flood the market with loads of pre-owned high mileage cars. So for us, we can potentially offer them a set price back to take the batteries off of them and put them into Qubes, which they then take the Qubes to charge up their next set of fleet that they buy. So you end up with this really cool circular economy, where all the electric vans out there, for instance, they come back into the fleets absolutely battered with doors missing, and you can't resell them. But we can take the batteries from them, because 9 times out of 10, the batteries are in perfect working order. The batteries are protected with BMSs. They're so well built, the car batteries, that they last so long. And to be honest, they're far safer than the energy storage batteries that are out there now, because these batteries in the cars have gone through so much testing. They've gone through fire testing, they've gone through vibration, flood testing. Like, you can drive these things through rivers and they still work, which obviously the normal sort of batteries that go into energy storage just don't get that level of testing that you do with, say, Teslas and other cars.
And also they are already, say, here in the UK, you don't have to re-import modules from China or abroad. Or I imagine if you were to build this abroad, you would use locally sourced second life battery packs.
Exactly. So when we start manufacturers in the US, for instance, there is thousands of Model 3 packs available in the US right now that we can start putting into charge cubes, or there's thousands of VW batteries. So there's so many, Ford batteries, there's just such a list of batteries that are available. And we've basically been working with Tesla parts and other parts since the company started with reverse engineering for retrofit. So we've sort of built up this knowledge base of how to reverse engineer a car battery to keep it in its original case, that we do not open the Tesla packs up at all. They stay completely sealed. I think that's the key thing. So we're maintaining the original Tesla BMS, the original pyro fuse, the original contactors. So all the stuff that comes as part of this pack to make it the safest thing possible is still there, still intact.
And also on the servicing aspect, it's very easy to service and even replace a pack if you need to. Any EV certified specialist could replace them.
Exactly. I mean, they stack up. So we stack them up to 6 high, as I said. We connect into the original HV connection points that are on the packs. We use the original liquid cooling system. Now, these things aren't getting hot at all because they're not getting pushed. The reason we run the liquid cooling system is that these are cylindrical cells, so you can end up with like random hot spots. So we still circulate cooling for like a minute every 10 minutes, just to make sure there's no hot spots in the battery and stuff. And then we have certain temperature settings, so if the inside the container gets to a certain temperature, it turns the fans on and the water pumps and starts circulating air to keep the temperature just right.
So the whole system thinks it is a car, or actually the battery pack is still in a car.
As far as the battery is concerned, it's still in a car. It's even mounted the same as it was in the car. We pick up all the original mounting points because that's how it was designed to be mounted. You do see a lot of these tipped up on ends on the side of people's garages and stuff, but as we've seen from people stripping these down online, they're not really, they will cope, but they're not ideally designed to be mounted like that. They're designed to be kept flat, which is why we try and keep every battery we do in the exact same sort of orientation as it came out of the vehicle.
What I find fantastic is, like, as you were saying earlier, 4 years ago, several companies came out like Redwood Material to recycle those batteries. But you show we don't need to recycle them for another decade or two.
We really don't.
And then they can be repurposed into new material and then become another battery in 30 years.
As we're seeing, the battery recycling plants just aren't coming online quick enough, but then at the same time, do they really need to?
Yeah.
Because they just don't, they last a lot longer than we think. Yeah, admittedly, there's been some issues with batteries out there, and some of the batteries will naturally go for recycling, where they've been in severe accidents or there's been manufacturing defects, things like that, recalls. Those are naturally going to have to be recycled, in which they might recycle, 98% of the battery or something. It's a crazy high recycling rate. But the thing with this is we're going to start getting these out in fleets all over the world, leased, rental, and we'll know when they're starting to come to end of life. So we can start working with recycling companies to start giving them batteries at the right point in time and then just refitting these with new ones. Now, I can't see that happening for at least 10 years or more, but you never know.
So is there a typical customer for ChargeCube?
Right now we're focusing on fleets and people that want to transition to electric vans and stuff like that, but there's so many other use cases for this that we're starting to see. Even events is one big thing, holding large amounts of power at an event, so they can then be distributed the power for, say, a weekend and then taken away and recharged on solar. So that's quite a cool thing. There's also something called hybrid generation. We may never get away from diesel generators with the flick of our fingers because there's not necessarily alternatives coming into the market. But what you'll find is on a lot of building sites that we go to, there'll be a large diesel generator running 7 days a week, and it will be powering up a laptop or some lights in a little container. And that diesel generator is complete waste. Like, it's just burning through fuel, not at peak efficiency. So this could sit next to it and basically turn that generator on for an hour a day, say at peak efficiency, charge the battery up, shut the generator down, run for the other 23 hours on battery power.
Or it could be a much smaller generator, and you could move it around different charge cubes throughout the day.
Yeah, because in a lot of places now is they'll size a generator for peak demand, even if most of the time it's only running at 20%.
Wow.
And obviously the engine is running, so that the engine's running, you may as well use the power from it because it's not going to increase its fuel burn by that much. And I know this stuff because I actually worked in a generator world for 6 years doing large power generation. So I've come from a background of big gen sets and I know how that world works. So ChargeCube fits into that world really, really well to make that hybrid system. And then also you're finding building sites now are having electric diggers. We've got a smaller version of ChargeCube in development, which is like the size of a pallet. So the plan with that is you can take it out to the digger to fill the digger up with electric wherever it is on site, rather than trying to bring that thing the whole way back to the charge point. And that's one of those barriers at the moment as well, is I'm running low out in the middle of a field, I've got to now drive the whole way back to charge up. So you're losing quite a lot of power. because they don't tend to do large mileage diggers. They tend to sit in one spot and pivot and move a lot, which obviously uses a lot less electricity. So going out to them to charge them is going to be quite a key thing moving forward.
It's funny because I was talking yesterday to an engineer at Volvo. They do diggers, mini diggers and so on, all electrics. And they only see one path for any work and construction jobs in town, say in London, but any cities around the world, and electric will be the only way. People are fed up with noise and emission in cities, so you definitely need more solution. And again, that's one aspect where Qube can certainly help.
Yeah, there's a huge amount of other things we're looking at. Same around, I don't know, like machining businesses, companies that are growing rapidly, don't have enough power, and you put one of these in to buffer their grid. So when they're shut down overnight, they charge up, and in the day, if they need more power to run machinery, they pull extra power from the batteries here to buffer the power they've got coming in. And you can also do phase balancing. I think that's going to be the other important thing long term for us further down the line, is that the grids all over the world get out of balance on their phases. So they basically waste a massive amount of electricity burning off as heat to try and balance phases back out again. With a battery pack, you can balance those phases, which we know there's other companies out there like Tesla and stuff that are already putting in large battery banks to support that. And that's working extremely well. So I think Qube sits in a really perfect little space to basically sort of service a huge amount of markets.
And being by definition a container, it is fairly mobile. You can move it easily. In a day you can install it, and within hours I imagine it's ready to go. And you don't even need to plug it into the grid for again for events. If you only need to top up vehicles, not charge them all the way up to 100%. One 6-pack Qube can charge quite a few cars at an event for a couple of hours.
Yeah, it really can. And then you've got the reliability side of things, in that you have no moving parts, which is key. Unlike generators, you're servicing all the time. These you're just not. And then we have basically cloud monitoring, so we'll be using Starlinks and things like that. So these are continually online. The key thing is they're online to AWS servers, so Amazon servers, so they're UK, US-based servers. None of it goes into, say, China. It's all kept within a local area, so we can see the data. It means we can track the charge cubes and go, well, how are they performing? Is one getting too warm? Is one running too low? And then we can, in theory, work with the customers to let them know way before there's ever an issue that they need to do some maintenance on the charge cube. Normally it's going to be change some filters, but we'll know about that beforehand, so we can do preventative maintenance and keep these things reliable really long term.
So how soon are we going to see this in other markets outside the UK?
So we're getting a huge amount of interest from the US market at the moment, and we're actively looking at now of how do we start building these in the US location. The key thing is obviously now we're at that point where we're raising lots of money. So we can build a big fleet of these and start deploying them out all over the world. One other thing that we did have a very good conversation with some people in Florida around recently was, can we use these for disaster relief? That's a big thing. You can have stacks of these pre-charged up in a yard, pick them up, drop them, and produce microgrids anywhere and everywhere after a disaster has happened. And that could be quite an exciting thing to do, to really help people in those situations, get their lives back in order and get them back moving forward again by just dropping one of these in and making a microgrid.
And we were discussing this earlier off camera. The National Health Service in the UK is looking exactly for a solution like this. And again, you're competitive price-wise with brand new battery packs coming from abroad, with the advantage of being built in the UK or the local market you'll be distributing from, and also managed, as you said earlier, in the local market, and helping convert classic fleet of ICE vehicles, van, ambulances. They cost a fortune to convert into ambulances, and those guys are going to have to find a solution to charge all those new e-vans, ambulances. So another aspect where the Qube could be shining.
Yeah, and they're going to want to be able to have priority. I think that's going to be the key thing. They're not going to want to use a normal supercharger somewhere, because it could be full when they need to get back out and save lives. So the thing with the charge cube is they could have one, say, in their depot, where they always go back to, that could just be for them. So it does 240 kilowatt CCS rapid charge, and they can pull in, drop a patient off, put a couple of minutes worth of juice in, go back out. I think that's the key thing, is charge is going to allow them to have power exactly where they need it, rather than having to go out of the way to charge, then go back out and help people and save lives. I think that's going to be quite a key thing of having these deployed in the right location, especially for blue light services all over the world.
So even for fleets distributing actually delivering, like say Amazon,
Yep.
they don't need a huge battery pack in the van itself. And when they have the same route pretty much every day delivering, UPS and so on, they could just have one Qube halfway through their route and just top up and then get on their way.
Yeah, and the thing with the cloud-based system is, in theory, you could track all the vehicles and know which ones are coming in when to make sure you keep enough power available in the Qube for that vehicle's recharge.
Yeah.
So you can start doing some really clever stuff with the algorithms and the data that you've got coming in from those companies to know how much charge is needed and when. Especially for, say, Amazon, they could drop one of these partway through a route, and they know on that route every day until the battery density goes up and energy density goes up, and then they don't ever need to do that. But that's going to take a period of time in order to get to that point.
Okay. I can hear the pump going.
Yes.
So why do you need a pump? It's not even, well, it's plugged in the car, but why do you run a pump?
We run the pump just in case we get hot spots. We like to keep track of the temperatures at all time. And the way the Teslas and stuff designed, there may be thousands of individual cells in there, but there's only a handful of temperature sensors.
Okay.
And they're only in certain points. So as much as you might say over the whole pack be sensing 6 points throughout that module, you're only sensing 6 points. So they require liquid to flow through to just dissipate the heat. Otherwise, you end up sensing one spot and you don't know how hot the other spots are. So it's just to get the liquid around, push the heat around so we know exactly what temperature they are.
Why was not this on the market 5 years ago?
We designed something 5 years ago to actually do something like this. But the issue is everything we designed was 48 volts.
Yeah.
Because all the inverters out there were all 48 volts. And the problem is the EV batteries always come in at around 400 volts. So you had to basically take every pack, strip it to pieces, rebuild it, and then you've got loads of batteries in parallel. And then loads of BMS systems.
Not ideal.
Not ideal, not cost effective.
Yeah.
No one would ever have spent the money on it. Whereas we're now at a point where we can build these competitive with sort of other countries that make them in volume, like say China, for instance. We can build them competitive with China, but we can build them in the UK or in the US or in Europe using batteries that are already in the country. I think that's the key thing, is we're recycling within, and we're not sending stuff back out the country for sort of recycling.
And you briefly mentioned earlier that you could use any type of EV battery packs.
Yep.
What would be the requirement to be something else on the Tesla, for instance?
For us, it probably needs to be a minimum of 50 kilowatt hours to make it worthwhile putting it in. The Tesla packs are great. Obviously, these are 78 or 77 kilowatt hours, I think. And obviously, there is the LFP version of the Tesla ones that we could put in here. So the other batteries we're looking at right now are things like ID4, maybe ID3, BYD, the BMW. The Nissan Leaf batteries are normally a bit small, and to be honest, the way the Leaf battery design, people keep taking them apart to use them for other stuff. But we're going to be focused on the battery packs that are really hard to take apart.
Okay.
So Tesla, those have 4 large battery modules inside.
You cannot
so
use them for anything
else. They're really difficult. You can't replace the BMSs easily, so they're hard work to use. So that's a perfect battery. The BYD have all the blade batteries in. You can't really take that apart. So as the OEMs are all transitioning to cell to pack, whereas they used to go cell, module, pack, they're now starting to go cell directly to pack and then building these structural packs that tie into the chassis. Those packs are the ones that we can use for this, and also those packs are a nightmare for recycling at the moment because you've got to separate them and put them through the shredder, which is quite hard. So using them in this for now makes perfect sense as the recycling processes are developed over time.
So let's dive into the system itself.
Yes, let's dive into the system itself. So we have power coming in from just over there, which is the thicker of the black cables. So we've got 32 amp 3-phase which comes in. That then comes in here and flows up into the inverter. Now the key thing is we take this into generator input of the inverter, so it's an appliance. It can never be feed back to the grid, which is the key thing here.
Okay.
This then takes the power in, and we have 2 DC buses here. So we have battery 1 and battery 2, which means the batteries aren't linked in parallel. It means they are kept separated. Because you're running different ages of batteries, if you link them in parallel, you can get really rapid degradation against the batteries, and you can get lots of problems. So this keeps the batteries completely isolated. So then basically the power comes in, can charge up the batteries, or what it can do is it can take the power in and the batteries, combine it together to output more power. So we can basically buffer the power in. We then basically have a fuse board here. So this has basically all of our breakers and fuses. So all of our different amp ratings and stuff, and they're all RCBO, so safety rated to stop people hurting themselves. And they then go out to all of the chargers. Then here, this is where we have the connection for the Model 3 battery. So Model 3 runs aluminium cables.
Okay.
Most people run copper. So that then allows us to do a nice connection to go from aluminium to the copper cables rather than have any corrosion issues long term. And then we have a safety shut-off for the 12-volt system to shut down. Then up here we have our brains. So these are basically 2 VCUs, one for each battery. But what these do is they basically take all the data that was in the car
Yes.
and make the battery still think it's still in a Tesla. But the key thing here is because we've done that and reverse engineered the CAN bus, we get every single fault code information. We get all the data from the BMS's whole life. So we get all this amazing data from the software that Tesla have developed, and we can use that to make sure we maintain the best health for the battery long term, which is a real key thing. I mean, obviously, all the OEMs do that, so all the other batteries we're going to start working with will also have all that data from them,
Okay.
which is a really, really good thing to have.
All right.
Now, this is our Tesla graveyard. So we basically have been taking accident damaged Teslas. We can take batteries straight from breakage yards as well. And we basically strip them apart, take the batteries out of them, but then recycle everything else. So it may come in this condition, which is a category B car, which means it can never go back on the road again. It is pretty battered, this one. As you can see, everything is massively caved in and damaged. And then they'll get completely stripped down and they'll end up sort of like this state, where there is nothing left of it. Everything gets recycled, even the quarter panels will get cut and then sent to other people that basically want to take them and fix their cars. So basically loads of Teslas, all in relevant different states, taken apart, and we use the batteries from them to go into the charge cubes. And then the container itself comes in a fairly good state. We then basically cut some holes in the side of it, input the chargers, all the power in, power out, then it goes off and gets painted. But that is how the container turns up to us, as you can see. It was a 20-foot container that's then been cut down and had basically a new front end fitted on it.
All right. Yeah.
Which is quite cool. And then we'll cut and in-point basically all the bits we need, depending on what the customer's ordered. Because depending if they want Type 2 or they want CCS and things like that, it depends on what sort of fittings we put on the sides of the containers.
How long does it take to convert a container into a charge cube?
The container into a charge cube is probably about a week with 2 to 3 members of staff. We're getting to a point now where we're starting to pre-build stuff. So the battery packs come in and they go through basically a big testing process. So we'll do rapid charge and discharge cycling on the batteries just to make sure they're really healthy and good, and we'll get them all the same voltage. Then we'll put them onto their racks and start racking them up, building all the power electronics and all the wiring stuff outside of the container, and then we start loading them into the container. So the plan is that the containers eventually, these will be assembled off-site, so they'll come into us with all the cutouts in already painted from a local fabrication shop, and we'll then do all the electronics and all the fit out at our premise. Actually in this building, which you can see is not actually been fitted out yet, but we'll get there very soon. So if you want to find out more information on ChargeQube, head to chargeqube.com. That's Qube with a Q. You can find out loads more information.